Today we're going to take a look at multiplying binomials with radicals in them. 3 binomials with radicals, so we have a lot of work ahead of us here. So when we are multiplying just binomials together, so let's just ignore this term here. We're just multiplying together, so we're doing this times this, so just distributive property twice, or you could use FOIL, but I typically use distributive property twice, and then we'll get this answer, so we'll clean all this up, whatever that turns out to be, and then we will deal with multiplying by this term. So I'm going to deal with this, just pretend that third binomial doesn't even exist, and I'll multiply the first 2 binomials together, get that answer, then we'll do a binomial times whatever that final term comes out to be. If this was like a binomial like x plus 5 times x minus 7, something like that, that typically turns into a trinomial, but in this case with radicals, certain things can happen where we get a radical times a radical and it ends up being like a perfect square, so then it simplifies down. Like, just weird things happen with radicals, so we don't really know exactly what's going to turn out to be. But let's just go ahead and do this. I'm going to do square root of 3 times square root of 6. So square root of 3 times square root of 6. When I'm multiplying radicals together, I'm multiplying the insides. So this is going to be the square root of 3 times 6, which is 18. Then from here, I can actually simplify that radical. Now, first of all, I kind of skipped this step, but there's no simplifying that could happen in the beginning here. I don't have any sort of like perfect squares. Like I don't have a square root of 9 that would just turn to a 3, or even like a square root of, let's say 12. That's 4 times 3. So then you would say square root of 4 is 2. That would break down to 2 root of 3. Like we don't have any of that in the beginning. So that's why I didn't even bother with that step. But now that we're multiplying, we might generate some scenarios where we can simplify. And like right here, square root of 18, this is 9 times 2. And the reason I'm not using 6 times 3 is because 9 is a perfect square, meaning when it's underneath the square root, like the square root of 9 times the square root of 2, square root of 9 is 3. 3 times 3 is 9. So we get 3 root 2 there. So square root of 3 times square root of 6 is 3 square root 2. Then we have square root of 3 times the square root of 7. So square root of 3 times the square root of 7, and I'll do that here. So square root of 3, and I'll probably erase all this once I'm finished. So square root of 3 times the square root of 7 is the square root. 3 times 7 is 21. Nothing happens there. So we just leave it as the square root of 21. So that's going to be plus square root of 21. Then I'm going to do square root of 5 times the square root of 6. And that's going to be minus because it's negative times a positive. So negative square root of 5 times the square root of 6. 5 times 6 is 30. So negative square root of 30. And there's nothing that we can clean up there, because 30 is 5 times 6, 5 is prime, then 6 is 3 times 2, 3 is prime, 2 is prime. So we can't do anything with that, so it's going to be minus square root of 30. And then we have negative 5 times the square root of 7. So it's going to be minus again, square root of 5 times square root of 7. 5 times 7 is 35, same discussion that we just had. I cannot do anything with that, so minus square root of 35. I'm going to go through and erase all of this work here, now that we're done with that. All right. What do we end up with? So we end up with this 3 square root of 2 plus 21 minus square root of 30 minus 35. I do not have any terms that I can combine together. I don't have any cleaning up that can happen. I know that 30, like that looks like, wow, there's got to be something that pulls out of there, right? Like there's got to be a perfect square. There isn't. There's no perfect square because 30 is 6 times 5. 6 is 3 times 2 times 5. Prime, prime, prime. We don't have the same number, like we don't have a times 2 where we'd have a 4, nothing like that. So there's nothing. So 30 is good. So now I have this term, this 4 term with radicals times this. So I'm going to be doing square root of 2 times that, square root of 2 times that, square root of 2 times that, square root of 2 times that. I'm going to be multiplying square root of 2 times everything, and then I'm going to take square root of 10, boom, 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 square root of 10 to everything also. So I'm going to do square root of 2 times 3 root 2, square root of 2 times root 21, square root of 2 times root 30, square root of 2 times root 35. So 3 square root 2 times square root 2 is the square root of 2 times square root of 2 is square root of 4, which is 2. Remember, if you're multiplying the same thing within a radical, you just get that same thing back, like the square root of 3 times the square root of 3 is 3, because square root of 9 is 3 times 3, which is 3. So you get back 3. A lot of side notes here. Radicals are interesting. So we end up with square root of 2 times square root of 2, which is 2. So 3 times 2, because whenever you lose out of the radical, when it comes out of the radical, it just becomes multiplication. So that's 3 times 2, which is 6. So that is going to be 6. And then I have the square root of 2 times the square root of 21. 2 times 21 is 42. So square root of 42, can we clean anything up there? No, because 21 is 7 times 3. So this is 2 times 7 times 3. 2 is prime, 7 is prime, 3 is prime. I don't have anything that's the same, like a 3 and a 3 or 2 and a 2. So that's just going to be, that's going to stay as the positive square root of 42. Okay, I'm going to erase as we go here. This is getting a little messy. Next, where am I at here? I'm at square root of 2 times the square root of 30. So it's going to be negative, so I'll just put minus here. So square root of 30 times the square root of 2, which is going to be the square root of 60. It's definitely something that could be taken out of there. There's a perfect square that goes into there. Now, it's not easy to find right away. You might not be able to just like, oh, it's this. So if you're not sure, what I would do is I would just start breaking it down. So 6 times 10 is 60. 3 times 2 is 6, and then 2 times 5 is 10. So that from here, I see, oh, I have a pair of 2's, meaning this is 4 times 3 times 5. So the square root of 4 is 2. So a 2 is going to come out of there, and then 3 times 5 is going to be left on the inside. So minus 2 root 15. And then we have 2 times 35. So the square root of 35 times the square root of 2. 2 times 35 is 70. And again, 70 is 7 times 10. 7 is prime. 10 is 5 times 2. I do not have anything, so believe it or not, square root of 70 cannot be simplified at all. So what sign is that going to be? That's going to be minus, because this is minus square root of 35. So it's going to be minus square root of 70. You'd think something would happen, right? Like you'd think something's got to come out of there, but no. 7 times 10, 2 times 5 times 7. Awesome. So we've taken care of the square root of 2. So let me move this down a little bit. Next, we are going to multiply the square root of 10 to everything. So negative square root of 10 times this, negative square root of 10 times that, negative square root of 10. And be careful with the negative square root of 10. It is negative, so you want to make sure you're taking the sign correctly. So 3 root 2 times 10. And that's positive times the negative, so I'm just going to throw in a negative there right away. So square root of 2 times the square root of 10 is going to be 3 square root 20. 2 times 10 is 20. 20 is 4 times 5. Square root of 4 is 2. So a 2 is going to pull out of there because the square root of 4 is 2. 2 times 3 is 6. So then we'll be left with minus 6 root 5. Next, negative square root of 10 times positive square root of 21. So that's going to be negative. So I'm just going to leave that there as negative. Just going to throw in that sign there so I don't forget about that. It's an easy mistake to make. So then we have square root of 21 times the square root of 10. Now we're going to get this inside the square root. So that's going to be the square root of 210. Before I do that though, since we're going to have to kind of go backwards to see if we can pull anything out, just look at 21 as 7 times 3. Look at 10 as 2 times 5. So even after I multiply, I'm not going to generate any sort of perfect squares or anything like that. So I can't, it's not going to simplify. So it's going to stay square root of 210 because there's no perfect squares that goes into 210. Even if I look at the numbers that multiply to 210, 7 times 3 times 2 times 5, there's nothing that's a perfect square there and nothing times itself. So I'm going to leave that as minus square root of 210. Another scenario where you think like, man, something's got to be perfect square there. Something has to clean that up a little bit. Well, why is that doing that? Is it something on my tablet? Okay. So then now I'm on the square root of 10 times the square root of 30. Got a little thrown off there. So the square root of 10, that's going to be negative times a negative, which is a positive. So the square root of 30 times the square root of 10. Do the same thing if you want. You can multiply it together just to get an idea of what we're going to be dealing with. So 30 times 10 is the square root of 300. And then I would just keep it like this so I could see quicker like what I'm dealing with here. So I see, first of all, 5 and 5. So that's 25. So I know I have a 25. And then I still have that 6 times 2. But what's interesting about 6 times 2 is the fact that I have 2 times 3. So then I have 2 times 2, which is 4. So that's going to be 25 times 4 times 3. And that just ends up being 100 times 3. So you didn't have to go through all the work, but I just wanted to show you in case you're not thinking and you get in that habit of just like, I'm going to break this down, find some perfect squares. But if you just think, oh, 300, 100 times 3, 100 is a perfect square because 10 times 10. Like you could have just done 100 times 3. Square root of 100 is 10, 10 root of 3. So there you go. So that's going to be 10 square root of 3. And then finally, the last one, and then we'll check if we have any like terms to combine. I highly doubt we'll end up with some like terms, but I'm not really paying attention yet. Excuse me, 35 times 10. So that's a negative times a negative, so that's going to be positive. So then we're doing 35 times square root of 10. 35 times 10 is going to be 350. 35 is 7 times 5, where 10 is 2 times 5. So we know, okay, well, 5 and 5 is 25. So 25 times 7 times 2, square root of 25 is 5. So then we're left with 5 square root of 14. Wow, quite a process. Let's check. Do we have any like terms that have been generated? So square root of 4. So when we're looking for like terms with radicals, they have to have the same thing on the inside of the radical. So it has to be square root of 14 and square root of 14. But in this case, I don't have anything. Square root of 42, nothing. Square root of 15, nothing. Square root of 70, nothing. Square root of 5, nothing. So nothing are able to be combined. So this is my answer. Quite a process. A lot of fun. I like radicals. They're a lot of fun. Cool things happen. But that is completely simplified. There's nothing else that we can do there. So hopefully that wasn't too bad for you.